And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho, editor-at-large of the Smash News Network, least busted name in news. Today we're showing you some composite imagery from the SDO of the Sun. This is 3 different wavelengths, all combined into one: 335, 193, and 94 angstroms, to reveal one sunspot in the northern hemisphere. Otherwise, not a lot of features to talk about. And the arrival of the coronal mass ejection, the coronal whole wind stream, was a complete dud so far. And it's even caused NOAA to move its numbers. We'll also be talking about NGC 6960, the Veil Nebula, the truth about cosmic ray flux, and a little bit about Sagittarius A star, the core of the Milky Way galaxy. Here's a colorized magnetogram. Sunspot 2812 has been pretty stable here over the past 24 hours, and that's the location of that. It is an alpha class sunspot with only North Pole oriented ombre. Here's another composite image here. This is 211, 304, and 171 angstroms. 3 different portions of the ultraviolet light spectrum. And let's talk some more data. Were you aware that women's menstrual cycles are affected by the phase of the moon as well as the moon's gravity? Well, it turns out it's a thing. There's an article about it on SciTech Daily today. I'll let it scroll here for all of you folks who like to pause our videos and read the articles. Correlation between moon phases, pregnancy, and birth rate. Don't have a dearth in your birth rate. Understand the connection between space and menstrual cycles. Speaking of cycles, here's the situation in the solar system. And for all you folks who are hoping that we were seeing a comet, indeed we were not seeing a comet, we were seeing Jupiter. Why? Well, as Eugene helped explain on Saturday night, stereo A is located approximately here. Stereo B is located approximately here. And when viewing the sun from stereo A, it's looking like this, which puts Jupiter to the left of the stereo A coronagraph. And as stereo A moves in this direction, it's orbiting the sun much faster than Jupiter is, which makes Jupiter appear basically stationary, which makes Jupiter appear to be moving in this direction. However, if you do look at it from the perspective of other stars in the background, it is indeed orbiting the sun in this direction. Hopefully that clears things up a little bit, and thanks to NASA's Stereo A team for responding to our email. Here's a star chart. Oh wait, I gotta advance this. There's where things are now. And there's where things will be in 1 week. Here's a star chart. If you're up before dawn, you may see Saturn and Jupiter rising ahead of the sun if you have clear skies. The radio flux of the 10.7 centimeter variety, which is emitted from the upper chromosphere and lower corona, in other words, this area right here, is at 75. So a weak radio flux. Don't be surprised to see sunspot 2812. Sunspot 2811. Don't be surprised to see it degrade. And here's the radio flux in context over a year. It's this black line up top. The red line at the bottom is the sunspot number. And I just wanted to bring up the comparison of cycles. So let's bring up this one here. And you can see solar cycle 25 started out a little stronger than cycle 24, and now it's approaching the exact same spot that cycle 24 was at. However, one interesting note is that the solar polar field reversal is nowhere near where it was during cycle 24 at this time. More on that later, as we'll be submitting a paper for peer review which explains the mechanism behind the solar sunspot cycles. So here's the Space Weather Enthusiast dashboard, which includes the NOAA alerts. And they've completely changed their alerts now. Now they're calling for a G1 geomagnetic storm late in the day today, within the last 3 hours of today. So at about 2100 tonight on March 29th, NOAA forecasting a G1 level geomagnetic storm. A KP of 5 is forecasted, as the coronal hole wind stream is showing up in weak pulses, which is why we said it's a dud. Check it out. Next, we're doing volcanoes, and Fagradalsfjall, have you learned how to say it yet? Fagradalsfjall is turning into a shield volcano before our very eyes. You can see it looks like part of the cinder cone has collapsed here, and you can see some lava fountaining happening there as it fills the crater valley with new lava. So some new real estate being created there as this cinder cone turns into a shield volcano. We've been covering it regularly on the channel, and how awesome is that? Thanks for leaving comments, Life Force Rejuvenation, who says he had a moon bath tonight. Insomnia bad. What else did you have to do? Well, you could have made sure your sleeping quarters is completely dark. Make sure your sleeping quarters is completely dark, folks. This could explain part of the correlation between lunatics, bad sleeping, in other words. You need your sleeping quarters to be completely dark, otherwise it will affect your sleep. Let's see what other volcanoes are erupting. Sakurajima uptick there in Japan. It's exploded and produced an 11,000-foot ash plume. Suwanosejima, 5,000-foot ash plume there. 12,000-foot ash plume at Sinabung in Indonesia. 2 volcanoes on the list in Guatemala. Pacaya exploding, 12,000-foot ash plume there. Fuego has dispersed its volcanic ash. Sangay and Revenador, both in Ecuador, are both exploding. Flight level 200 and 140 respectively. Sangay is producing a 20,000-foot ash plume, and Revenador is producing a 14,000-foot ash plume. Sabancaya in Peru, unable to detect that. Please do not pole vault the caldera. And Piton de la Fournaise is showing a decreasing trend in carbon dioxide and sulfur dioxide emissions. So the seismic activity has also decreased, a slight decrease in the likelihood of major eruptions on the Isle of Réunion from Piton de la Fournaise. Next, seismicity over the past 24 includes some earthquakes, no major ones. One of them was this deep quake here at 1349 yesterday at Tonga. One of the spots I'd like to visit someday. It's a 4.6 magnitude at 273 kilometers. Let's check out the location of that. And pretty much in the middle of nowhere. Check out this island. It's shaped like a crater. The Isle of Futu, I think it is. Anyway, back to the list. Close. There we go. So again, it looks like the largest of the past 24 may have been this 5.8 in the Mid-Atlantic Ridge, a 5.8 magnitude quake there in the middle of the North Atlantic. And only 7 minutes later, we saw a deep quake at the Kermadec Islands. Somewhat on the other side of the world there in the South Pacific, north of New Zealand. That 4.6 magnitude quake at over 500 kilometers depth. Deep quake at Guatemala, a 4.6 magnitude. .5 at Barbados, pretty far east for a Caribbean quake. And continuing on, back to some data from the GO-16 and its sun-facing instrumentation. Includes X-ray detectors. There's the data from it. No solar flares over the past 24 hours. Nothing making it into the B-class range, at least. No proton strikes on the magnetosphere, and no surprises there. We would have probably forecasted it. And thanks again for leaving comments, Mr. Katowski. Or is it Katowski? I don't know. Cheers. So no strikes on the proton flux there. Also measured by the GO-16 in its geosynchronous high-altitude orbit. The GOES magnetometer, there's the data from that, and the Earth has moved into the North Pole current sheet. So the North Pole current sheet, we've been showing it arriving for the last couple of days. I didn't forecast this one, but there it is. Keep in mind the data is 1 hour and 12 minutes old, and the Earth most likely has already snapped into the North Pole current sheet, shown here in green. Here's the latest image, and while it still shows the potential field surface source line over here, I think it's probably by now over here. Over here. Anyway, that's the top view ecliptic plane field plot, part of the National Sunspot Observatory suite of data, and it's pretty sweet data. It's showing you the polarity of the heliospheric current sheet, as well as all kinds of information about plasma suspended out in the corona. All these areas are areas where the potential field surface source lines bunch up, an indication that plasma is aligning to and being heated up by magnetic fields. Here is the line of sight coronal hole plot. It shows you the sun's B field in blue, and you can see a large coronal hole covering quite a bit of area here in the northeast, rotating into the Earth-facing portion of the disk. We'll keep you posted on that one in future videos. It's the line of sight coronal hole plot. And here is the detected filaments and detected sunspot groups. Again, sunspot 2812? I thought it was 2811. All right, I recorrect myself. Sunspot 2812 remains alpha class. It has only North Pole oriented umbrae, folks. And we do see some filaments here that are not showing up. There are some filaments around this area that are not yet showing up because of contrast. And we'll just continue on here. The KP index and measurement of global geomagnetism currently at 1. And it looks like the KP index is giving us the finger, folks. What's up with that? Is the KP index giving NOAA the finger for forecasting geomagnetic storms that never came? At least haven't come yet. Next, the real-time solar wind. BTBZ is pretty uneventful. Phi angle is pretty uneventful. And we're seeing a small uptick here in the solar wind density going on for the past about 10 hours. Current conditions are solar wind density 6.18 protons per cubic centimeter, solar wind speed barely even above baseline levels here at 330 kilometers per second. That is not what you would call a high-speed coronal hole wind stream. Continuing on to the geospace magnetosphere movies, which we show daily, by the way. So here's 4 hours of data of magnetohydrodynamic pressure measured in nanopascals, and you can see a quite homogeneous pressure here. It may ramp up a little bit at the end as the density increased. And you can see a tiny uptick there in the bow shock region, which would be to your left, where the sun would be located on these imageries. These are 90-degree differences here. One is the equatorial plane, and the other is the meridional plane. The one on the left is as if you're viewing the Earth from above at the pole, and the other one is if you're viewing the Earth from the side, looking at the meridian, the prime meridian, for example. A vertical line, if you're viewing the Earth in the standard map view with north up and south down. Here's 4 hours of ground magnetic perturbations. This is changes in the Earth's B field, otherwise known as geospace delta B. And like the last geospace magnetosphere movie, this is all based on the space weather modeling framework. If you want to read about it, look up the geospace magnetosphere movie, scroll down to the bottom, click on details, There's a link for the Space Weather Modeling Framework, which will explain all the variables that are used in these models. No real surprises there. By the way, we are streaming live to Twitch thanks to our new follower over on Twitch. Most of our content is on YouTube, so if you're viewing on Twitch or BitChute, make sure you follow on YouTube as well, youtube.com/smAsho. And don't forget to check out our playlists, as there are all kinds of other topics covered on the channel besides space weather. Thanks to our subscribers on BitChute as well, and we're almost at 400, and let's do a cosmology segment. Because here at the Smash News Network, we are interested in cosmology, as I and many others believe that it is super important to all sorts of things from climate and more. So Least Busted Name in News continues on here with today's cosmology segment. Let's talk about cosmic ray flux. As you will see at the Oulu neutron monitor, as well as Mexico City and other neutron monitors, cosmic ray flux is not as high as it was in 2010. So I brought up this chart here to intentionally cherry pick the data. This is the highest cosmic ray flux ever measured. This is not, as you can clearly see on the Oulu neutron monitor. Now, there is a disparity that happens between solar cycles, and I can't get into that in this video because it's going to appear in later content. But I brought up the graph here from 2009 to 2021 to show this obvious fact. These levels are the highest cosmic ray flux ever measured, and any YouTube channel suggesting that these are the highest levels ever measured should either watch our videos or stop lying to their viewers. Let's talk about NGC 6960, the Veil Nebula, and check out the imagery. All these filamentary areas in here, these strings of material, and it's a chemical soup, folks. It's a chemical soup. Anyway, there's an interesting article about it here on SciTechDaily.com. The spectacular return to the Veil Nebula. So some great imagery here by the Hubble Space Telescope. And again, this is including ionized oxygen, ionized hydrogen, and ionized nitrogen, shown respectively in blue for the ionized oxygen and red in the ionized nitrogen. No indication of what color the hydrogen is. I guess green? I don't know. I think it's probably the green part. I have no idea. You think they would have let us know? So this is located 2,100 light years from the Earth, 2,100 light years, and is located in the Cygnus Loop. Fantastic imagery there from Hubble on the Veil Nebula, otherwise known as NGC 6960. And I just wanted to show you this in some additional wavelengths here. So here's Finkbeiner, which is hydrogen alpha. And you can see there's lots of hydrogen in galaxies and really all around space. And check it out, some huge filaments of hydrogen associated with this area. And we're also going to show you some other wavelengths here. So here's optical, bands Z and G from Pan-STARRS. Let's center that again and zoom in. So there's a great view of the nebula as well, in just 2 optical bands, folks. And we'll also show you, let's see here, how about blue light? And you can see it is a feature-rich region of space, to say the least. NGC 6960, otherwise known as the Veil Nebula. Now let's pick a totally non-random object. Today's totally non-random object is Sagittarius A star. Now, why do we talk about Sagittarius A star? Well, it's kind of important, folks. And so here's what's going on at the core of the Milky Way galaxy. Those are all supermassive blue giant stars, which are much more massive than the sun, and they orbit in, some of them in more circular orbits, some of them in highly eccentric orbits, as you can see this one here that's coming right to my face. Wait for it. There's that highly eccentric orbit. And so the point is, folks, what's going on at the core of the galaxy is absolutely nothing like what's going on in the solar system. These stars are orbiting the galactic core on multi-different planes, so there's no coherent galactic core disk, and the interaction between all these stars, we really have no idea what is honestly going on fully, because we're only able to see the core of the Milky Way galaxy in certain wavelengths. So in any case, this is one of the animations, and you can find lots of animations. We can't see the object around which these other objects are orbiting, but those objects are large massive stars that are orbiting like grains of sand around the massive radio source at the core of the Milky Way galaxy, known as Sagittarius A star. Now, what we normally show is just this, which is a high-resolution background of a small, tiny portion of the Milky Way galaxy. It's actually the Big Dipper that we regularly show on the channel. And so now we're going to show what goes on as far as X-ray emissions from the massive radio source at the core of the Milky Way galaxy. And there are the X-ray transient bursts. You can see here, this is the approximately 16-year chart of the X-ray output of Sagittarius A star. And here's the 30-day chart. We did see a pretty strong burst here about 20 days ago. And you can see that made it all the way up to 0.17, which would be off of this chart entirely. That would be like way up here on that chart. But otherwise, it's a pretty consistent X-ray source. And if you want to look up your favorite transients yourself, head to the Neil Gorell Swift Observatory. The Neil Gorell Swift Observatory, the Burst Alert Telescope. And you can look up all your favorite objects there, perhaps. In fact, let's see if we've got NGC 6960. I think it'll probably be there, but indeed it is not. So one of the other X-ray sources you may look up is the Crab Nebula, right? The Crab Nebula is one of the most consistent and strongest X-ray sources in the entire Milky Way galaxy. And it's such a consistent source that it's actually used to calibrate equipment, like X-ray telescopes. There are the transients from Crab. Don't be a crab. And I don't know why I have a query for Sagittarius A star here. Let's close that tab entirely. And that's today's cosmology segment. Let's continue on here at the Smash News Network with additional data. So here's the 1-year chart of the electron flux. This is measured by the GOES-16, and it's measuring the electron flux at the ionosphere level, which is at about 300 kilometers of altitude, while the GOES-16 is at like 25,000 miles of altitude. It's using radiometers to make those measurements, and here is the 3-day chart as measured by the GOES-16 in its Earth-facing suite of instruments known as the advanced something or other, the ABI on the GOES-16. You can read all about it on Wikipedia, and you can see a bit of a cratering here of the electron flux as we forecasted for the arrival of the extremely weak coronal hole wind stream. So here's the forecast for electron flux, which is reflected in the green boxes. The yellow diamonds are the observation, and no comment on that. So here's a diagram, and GPS satellites are actually located at a lower altitude than the GOES-16, which is actually more like outside the outer Van Allen belt. Your GPS satellite is in between the inner and outer Van Allen belts at about 12,500 miles. We put up that diagram daily because we're going to show this next, the total air column, the total electron content forecast between geosynchronous satellites and your GPS handset. And this will show you where GPS errors are likely to occur. We see more anomalous electron flux areas during times of coronal hole wind streams as the electron belts get a little disorganized. When coronal hole wind streams strike, nothing too exciting to comment on there. Here's a diagram of the atmosphere, a closer in diagram. And we're showing this because we're going to show the F ionosphere layer next, which is right around this altitude here, around 300 kilometers of altitude, the F ionosphere layer. Here's the D layer, here's the E layer. And I would also note it shows the troposphere, the location where all of your weather occurs, the portion of the atmosphere in which you live. So here's the ionosphere map, and we show this one daily as well. A little bit anomalous here, some sudden charge ups and charge downs that you'll see on the F ionosphere map. This one's provided by Australian Government Bureau of Meteorology, and each movement here represents 15 minutes, so every second is showing you 15 minutes. And we're seeing some wobbliness here in the ionosphere and some sudden charge ups and charge downs. And you can see that reflected in places like the Central Atlantic. And it's a good time to show folks where the South Atlantic anomaly is. The South Atlantic anomaly is someplace around here, which it has recently split into two, by the way, folks. There's also a South African anomaly down here, and you can actually see some ionospheric effects there around my pointer. There's a sudden charge down. So some anomalies here in the ionosphere, and we show it daily. There's the latest image at 9:45 Universal Time. Next, looking at surface winds. As we move into the realm of meteorology, let me check the life of the stream to make sure everything is copacetic. Life Force Rejuvenation comments, badass. Well, thank you. We try. So here are surface winds of the western world. Next, we'll move to the jet stream. And here are the jet streams. Extreme meridional jet stream flow once again over the North Atlantic, as well as doubled up jet streams in the southern hemisphere, the southern hemisphere, southern. Shout out to our southern hemisphere viewers. And here are the jet streams of the eastern world. We do see some jet streams blowing backwards again, once again over the western Pacific and the Indian Oceans. Here are surface winds. Since we showed you the western world, here are the eastern world. And pretty anomalous looking system here. We've got very strong winds in the southern portion of this low pressure system and weaker winds in the north portion. This system here southwest of India. And continuing on with meteorology, here is the pressure scenario. And we'll advance this into the GFS forecast. Here's the GFS forecast for pressure. Tomorrow, noon Eastern time. And if you're wondering where we're located, SMASH staff and I are located right about there in Lehigh Valley, Pennsylvania. Come visit. It's the ultimate, it's one of the biggest cycling communities in the world, folks. Trexlertown, Pennsylvania. If you've never looked it up, check out Trexlertown, Pennsylvania. Location of the Valley Preferred Cycling Center. Thousands and thousands and thousands and thousands of riders ride out of there on the regs throughout every year. Next, real-time lightning map, and we see some lightning here in the North Atlantic. Pretty much no place else in the world right now. I use lightningmaps.org when I hear thunder. Shout out to blitzortung.org. Drop me a line. We'll feature you on the channel. Next, the U.S. Doppler radar map to see some snow falling in most of New York, western Pennsylvania, northern Wisconsin, western Montana, northern Idaho, Washington, and Oregon, as spring continues and snow continues to fall. Here's a image of the clouds This is the NASA GOES Interactive Weather Satellite Suite. We're looking at the shortwave 3.9 nanometer radiation map to show you clouds when it's too dark to see them using the visible. Here's water vapor. And it looks like some interesting systems here over Colorado. We're going to zoom in to see what's going on with all that hot air coming out of Colorado. So I'm going to zoom in on the corner of the Oklahoma Panhandle here, folks, to get a great view of this. We see some interesting cloud formations likely to be happening there, as there are some funky pressure gradients, probably caused by all the hot air coming out of Colorado. So here's what's going on in the cloud layer. Pretty uneventful. But when you look at the water vapor map, you can see all of those pressure gradients. And part of this is caused by orographic lifting. And what that means is when air is moving like this and it reaches the mountains, it's forced up. And when it's forced up, it causes a pressure increase. And that pressure increase does things like causes clouds to evaporate. And again, there's the cloud layer, and there's the water vapor. And some moisture moving down. Probably going to create some precipitation in places like Nevada and Utah. Next, we're going to show you the most recent images of the local yellow dwarf. And this is only 1 hour and 1 minute and 43 seconds old here from Udaipur, India. Udaipur, India, yes. The National Sunspot Observatory ground-based system. You can see some filaments up here, some filaments up here, filament out here. You still really can't see this one. There is a filament in this area, folks. And there are some down here as well. I would also invite all of our viewers to check out our own websites and welcome everybody viewing the videos to the Neo Renaissance, as we are about to write a paper explaining the mechanism behind the solar sunspot cycles and solar polar field reversals. If you weren't aware, well, we're happy to inform you. Today's featured product is... What the heck is today's featured product? It's not our patrons. Our patrons are our featured product, but featured product is the Mansa shirt. So I'm actually wearing one today. And let me bring that up. The Mansa shirt, folks. Make America not suck again. Yes. Have you noticed America sucking? Would you like to hold certain officials accountable in 2021, the year of accountability? Well, pick up a Mansa shirt. It's completely nonpartisan. That's not some kind of a Trump dig or a Trump endorsement or anything like that. That's Make America Not Suck Again. It's up to you, not the government. So check out our merch. Again, you can link to it at smashomash.com. This particular site is the Smash merch, the smAsho store. So if you click that, it'll direct you to this Teespring page, and there's the Mansa shirt. Mine is in purple. Make America Not Suck Again. It's up to you. One of the parties making America not suck again is our patrons. So perhaps consider funding our operation, as YouTube algorithms are helping us to make almost nothing ever on YouTube. Our URL for our Patreon is patreon.com/smashomash, and thanks to our patrons, new and old. Thanks to the Smash team for watching the video, leaving comments, etc. Please share with your friends, your foes, your science noobs, and your science pros, as we've got bonus features, such as a close-up of Sunspot 2812. It's the ultra-high resolution magnetogram. And what about the ultra-high resolution intensitygram? Well, we've got that too. So there's the magnetogram, there is the intensitygram. And it's actually degrading here. This is looking weaker than it did when I did show prep only about a half an hour ago. This thing could lose its name today. Trailing umbrae are looking weaker as well. And we've got some additional imagery of the sun here. How about the composite image? in 171 and colorized magnetogram. So you're looking at UV emissions of ionized iron, as well as the magnetogram, which is those colors besides that goldish, sort of a mustard color, to show you things like field polarity. And I think we've got one more. It's the, I gotta refresh that, I apologize for the flashing imagery. It's 94 angstroms. So thanks for tuning into the Daily Space Weather, folks. Remember, stare at the sun, attempt to understand the physics, don't drink, but if you do, don't drive. And don't forget to visit our links, press like, press subscribe, share with your friends, foes, science noobs, and science pros. And since it'll never be now again, may that solar wind be at your back.